A heat exchanger is a device that transfers heat between two or more fluids of different temperatures. There are many types of heat exchangers, such as shell and tube, plate, double pipe, finned, adiabatic, and phase change heat exchangers. Heat exchangers are used in the oil and gas industry for various purposes, such as refining, liquefaction, cooling, condensing, vapors recovery, and steam generation. The maintenance of heat exchangers depends on the type, design, and operating conditions of the device. Some common maintenance tasks include cleaning, inspecting, repairing, and replacing parts of the heat exchanger. As I mentioned before, there are many types of heat exchangers, such as shell and tube, plate, double pipe, finned, adiabatic, and phase change heat exchangers. Each type has its own advantages and disadvantages, depending on the application and the fluids involved. For example, shell and tube heat exchangers are widely used in the oil and gas industry because they can handle high pressures and temperatures, but they are also bulky and difficult to clean. Plate heat exchangers are more compact and efficient, but they are prone to fouling and leakage. Double pipe heat exchangers are simple and cheap, but they have low heat transfer rates and require a lot of space. Finned heat exchangers have enhanced heat transfer surfaces, but they are also susceptible to corrosion and erosion. Adiabatic heat exchangers use intermediate fluids or solids to transfer heat without mixing the fluids, but they are complex and costly. Phase change heat exchangers use the latent heat of vaporization or condensation to transfer heat, but they require careful control of the pressure and temperature. Heat exchangers are used in the oil and gas industry for various purposes, such as refining, liquefaction, cooling, condensing, vapor recovery, and steam generation. The type of heat exchanger that is suitable for each application depends on the fluids involved, the operating conditions, and the design requirements. Some examples of heat exchangers used in the oil and gas industry are: shell and tube heat exchangers are used in cracking units, where they break down the hydrocarbons in crude oil into smaller pieces. They are also used in liquefaction plants, where they cool down natural gas to a liquid state. Plate heat exchangers are used in condensers, where they turn vapor into liquid by removing heat. They are also used in evaporators, where they turn liquid into vapor by adding heat. Double pipe heat exchangers are used in fuel gas conditioning skids, where they remove water and impurities from natural gas before combustion. They are also used in lube oil systems, where they cool down the lubricating oil for machinery. Finned heat exchangers are used in air preheaters, where they heat up the air before entering the furnace or boiler. They are also used in cooling towers, where they cool down the water by transferring heat to the air. Adiabatic heat exchangers are used in selective catalytic reduction units, where they reduce the nitrogen oxide's emissions from flue gas by injecting ammonia. They are also used in cold ammonia flow control, where they regulate the flow and temperature of ammonia for refrigeration. Phase change heat exchangers are used in boilers, where they generate steam by heating water. They are also used in vapor recovery units, where they recover vapor from storage tanks or pipelines by condensing it. Shell and tube heat exchangers are a class of heat exchanger designs that consist of a shell, a large pressure vessel, and a bundle of tubes inside it. One fluid flows through the tubes, and another fluid flows over the tubes, through the shell, to transfer heat between the two fluids. 123. Shell and tube heat exchangers are the most common type of heat exchanger in oil refineries and other large chemical processes, and they are suited for higher pressure applications. Shell and tube heat exchangers can have different configurations, such as parallel flow, counterflow, or cross-flow, depending on the direction of the fluid flow. They can also have different types of tube layouts, such as triangular, square, or rotated square, depending on the arrangement of the tubes in the shell. Moreover, they can have different types of shell and tube passes, such as single pass, multi-pass, or divided flow, depending on the number and division of the fluid streams in the shell and the tubes.